Hi guys, in this video I'm going to be taking you through the top interview questions for a data scientist. I'm Nitika Bajwa and I come with 4 to 5 years of experience in this domain myself. I've worked at Amazon in the fintech department and currently I'm associated with OdinSchool. OdinSchool is an upcoming platform for working professionals who want to upskill themselves or learn new technologies to stay up to date in the current market. So before we go ahead with this video, please like and subscribe to our channel on YouTube. Okay, so before we get into the individual questions, let's have a look at the different types of interview questions. So a lot of times the interview questions are not like question and answer, it's not an exam. The interviewer is judging you on your personality, your rate of response, the way you react. And it is very important to keep all of these in mind before going for an interview. So I've broken the interview questions into two types. One is company based. So obviously, each one of us has our dream companies where we wish to achieve our dream role. So I've chosen a couple of the top known companies like Google, Amazon, Facebook, and sorted the questions based on these tags as to which company is more likely to ask these questions. The other is category based. So in category based, I've divided the questions into four types. Let's look at the first one, content questions. So content questions are very content oriented, nothing else. This is again broken into two categories. One is your direct or theory questions. These would be very direct. What is standard deviation? What is linear regression? Very direct to the point, you give direct answers. The other is application or problem solving. So this is where they, use the knowledge and try to ask you little twisted questions to see how would you apply that knowledge and if you do have the potential to even apply it. As a data scientist, this is something that is very important. So I would really ask you to focus on application based questions. And I'm sure you must have heard, like everyone knows that Google as a company is known to have one of the most difficult interview questions. This is because Google generally does not ask more of the direct questions. They believe in asking more of the problem solving or brain teasers to see if the candidate is fit. So apart from content type, we have three other types. One is past experience. So a lot of companies try to look into your past experience. This is not just to see if you do have the same or relevant experience. It is also to understand if you're able to associate your current responsibilities with what you're applying for. So if you are a data scientist with non-data scientist background, are you able to apply certain problem solving or analytical skills? Are you able to demonstrate that you've applied those in your previous experience? This is in fact one of the strongest indicators to interviewers that you do have a strong grasp of the knowledge. Apart from this, so we have personality questions. Personality questions are more to determine if your skill set match the job you're applying for. So again, for a data scientist, problem solving would be one of a huge skill set requirement. So they would often ask you questions and see how you generally deal with problem solving sort of questions to see if you have what it takes. The last one is team fit and ethic questions. So this is often asked by big corporations to see whether you even fit into the team. You might sometimes have all of the skill and everything it takes for the role, but might not fit into the team, which could lead to clashes and delays in work. So, a lot of companies also focus on team fit and ethic questions. So, now that we have understood the different types of questions which will be used as tags going forward, let's move on to the questions. So, first one, before I get into the question, I just want to explain the format of how I'll be taking you guys through each question. So, as I've already explained, there will be tags associated with each question so you can understand what type of question it is. Apart from that, I'm also putting other ways to frame the question. So, this will help you identify, when the same question is put across in different ways, you'll easily be able to identify and answer quickly. And the last is tips to answer questions. So obviously, as I said, going for interviewer is a lot about, understanding your interviewer and seeing what he wants. So I'm going to be giving certain tips as to how to answer certain questions and what the interviewer might have in his mind that, he's checking off or judging you based on. So let's get started. The first question is, what are the roles of a data scientist? Please highlight the responsibilities that you feel best suit you. So this is actually a very basic and direct question, but also one that you probably might get asked a lot because any company which is hiring you would obviously want to know that you know the basic responsibilities of your role, because that is something that they would not want to invest time on training you on. There's already a lot to be trained on. So let's move on to the answer. What are the roles? So first one, it is super important for a data scientist to be able to identify different data sources, see if those data sources are structured, unstructured. So, what do we mean by structured or unstructured? Structured would be, is the data in a format that is easily usable? Is it relevant to what you require? Does it include everything? Unstructured would be data that has not yet, been looked at or sorted into how it can be easily used. So from a starting standpoint, this is quite important for a data scientist, because whenever you're starting up, say, a new operation and you need to set up the databases and everything, it will be your responsibility to ensure that you're collecting all of the data, getting it in the format that is best for your team and most usable. So apart from this, most obvious one, obviously, analyze large amounts of data. As a data scientist, we all know we have to look at a lot of data and try to identify different trends, see what are the common trends, how can we address them, what outliers can we identify. So outliers are nothing but something that stands out from the common data standpoints. Next is creating predictive models and machine learning algorithms. So this is again often your data might be there, but it might not be solving certain business problems. So you might need to understand how to play around with the data or how to model it in a way that helps you solve your problem. So coming up with those sort of algorithms or strategic models is also the role of a data scientist. And next, presenting information using data visualization. So obviously you need to know a lot of data visualization tools, Excel being the most basic, others being Tableau or Click. So these are all very good tools and tools that as a data scientist you are expected to know, because these you help you, tell the story that the data is letting you know. And in fact, one of the skills that they would definitely look for in a data scientist is, can you interpret what the data is telling you? Because you might be able to collate the data and everything, but if you cannot interpret what it's telling you, you will not be able to communicate that to your stakeholders. And data scientists are the biggest liaisons between technology team and the stakeholders. So it is very important to be able to understand the data and interpret it for your stakeholders, because that is kind of what your key role is. So moving on to the next question, describe decision tree, SVM and random forest. Talk about their advantages and disadvantages. So this is a very simple theory based type of question, and in fact it is one asked quite often by Amazon. So let's start off with decision trees. What exactly are decision trees? So I have chosen over here a fun example to help you understand what a decision tree is. So I'm sure all of you must have watched Harry Potter. If not, I really recommend watching it. So Harry Potter has four houses, and the sorting hat sorts each candidate who comes to the school into these four houses. And we all know that these four houses represent certain qualities, and based on the qualities, the people are sorted into the houses. So the people who are a little more emotion based are usually sorted into Gryffindor, who is known for bravery and loyalty. And people who are emotional, more soft, caring are put into Hufflepuff. A slightly non-emotional bracket of people belong to Ravenclaw and Slytherin, with more, so smartness is in both, but using the smartness for kind of things is kind of seen as Ravenclaw, and being a little more cunning is something that is seen as Slytherin. So if you see over here, emotional, yes, no, it goes to the next bracket. Brave, yes, Gryffindor, no, Hufflepuff. Cunning, yes, Slytherin, no, Ravenclaw. So that is exactly how decision trees work. They take your decision and break it into simple answers. If it is a yes, what happens? If it is a no, what happens? So this helps you easily plan through the next steps and see what are the different predictions and possibilities that can occur. So the different pros and cons of using decision trees. Pros are it's easy to implement, it's intuitive, handles missing values. So anything where you know, okay, if we do not have the persons, is the person brave or not, we automatically know that we might not be able to sort the person. So it helps highlight such missing values very easily. The con could be a little bit of high variance. Not everything might fit into this because over here only brave and cunning has been chosen, but suppose some other factor comes in which is not included over here, so there are a few cons where it ends up becoming a little inaccurate. So coming to support vector machines, support vector machine is this algorithm which tries to classify data. So how it does it is by classifying it into two brackets. So if you see over here, it's segregated into two sections. One is blue squares and one is green circles. And it does this classification by trying to find the maximum margin between them and then choosing an optimal intermediate, right in between sort of hyperplane that can segregate the two data points. So it has certain pros and cons. One of the pros is that, in the future, whenever you get a bigger data set or more data points, it is very easy to classify because of the huge distance. You're sure of your two classifications. Certain cons of it is that because we are maintaining such a high margin and, we have put it as a high focus, we tend to ignore data points which might not be fitting into these two classifications, which could lead to us trying to overfit the data. So overfit the data is nothing but when the data is trying to fit whatever logic we have given it to perfectly fit the norm as such. So coming to the next, which is random forest. So random forest is nothing but accumulation of a lot of decision trees. So as you can see over here, we have tree 1, tree 2, and tree 3. When we discussed the decision trees, if you remember, we talked about how a decision talks about the different scenarios. So in this scenario, what happens is because it's accumulation of a lot of different trees, it takes the individual decisions of all of them and that cumulatively tries to take a predictive decision. So again, coming to the pros and cons of this, the pro is that the accuracy is very good and we can always increase our sample set to get even more accurate answers. The biggest con would be that this can often go into an infinite loop on a black box. The other is that computationally it can be quite hard on the system if you put too many decision trees because it takes that much computational power. So coming to question number 3, what is overfitting? We already discussed this a little bit in the previous question. So overfitting is when your data tries to, the model tries to fit the data too much as per the logic. So what happens is with your data, and if you have given the logic too strictly, your data tries to happens to go into three buckets. One is underfitted, where it will ignore a lot of these data points just trying to fit the logic and end up taking only few. The second one is a good fit. So this is where it keeps all of the data points in consideration. So we should always try to get our model to give a more good fit, give more good fit results. Last one is overfitted. So overfitted is when it tries to take each and everything, often missing out on common patterns or outliers that are there because it's trying to fit each and every tiny detail. So that is what is coming to question 4, what is L1 and L2 norm? What is the difference between them? Another way to frame this question is what is regularization and what are the different techniques? So L1 and L2 are nothing but different regularization norms. Regularization is the process where you add additional information. So in case certain data is, you feel it would help model the data better, in that case you add certain additional information. So this is done with a lot of predictive analysis, and only then do we put in data. So coming to L1, L1 norm is called lasso regression, L2 is called ridge regression. So the difference between them comes in how we calculate the two. Usually L2 is the more preferred one because L1 is not that commonly taught, but I think it's good to know both since it could definitely be asked as an interview question, and it's good to know. So starting with L1. So in L1 what happens is, suppose you have two vectors, considering this red dot to be one, and over here you have another vector. So when you take the distance between the two, how would you measure it? You would take the absolute value of x coordinate and absolute value of y coordinate. So that's how you would add the two and get the sum. So that is what L1 calculates, and that is the formula for L1 norm. L2 norm is more based on the hypotenuse. So in case you guys know the Pythagoras theorem, then you know that's used to calculate the hypotenuse. So it takes the square root of the sum of x square plus y square, and that would give you the radius over here, and that is why it is represented as a circle. And if you see L1, where you take the absolute value and the sum of those two, it is represented as a square. So I think it's pretty simple and it is good to keep in mind, but just remember that the L2 is normally preferred. Question 5. Explain what is imputation. What are the different types of imputation techniques? Which imputation method is more favorable? So the other ways to phrase this question could be, how would you handle or tackle a situation where certain of your data points are missing? Since they have asked which imputation method is more favorable, a tip to keep in mind over here would be whenever they ask for which is more favorable, always do stress on what your choice is, and if you have used it in the past, why would be that your preference? And in case you have certain examples, do share. So, imputation basically is the process of adding data when certain data is missing. It can be done in two ways, single imputation and multiple imputation. So, single imputation is when you replace the data only once. Multiple imputation is when you try several iterations of replacing the data and then take the pooled response. So, this is an image that shows when to use single versus multiple imputation. So, usually we tend to prefer the single imputation because of its simplicity, but honestly, multiple imputation is still preferred because of the accuracy. So let's look at this diagram and see when is single imputation actually preferred. So in the first case, is it valid to ignore missing data? So the general rule of thumb is if more than 5% data is missing, that is when you would go for multiple imputation. But if it is less than 5%, you would generally ignore it or use single imputation. So over here, if it is less than 5%, then the next thing you would test for is it too large? So if it is again too large bits of data that is missing, then single imputation might actually alter the results way too much, making it untrustworthy. So if large proportions of data are missing, then you might want to consider something else. Last, is data missing only on the dependent variables? So in case your data is missing on the dependent variables, then you would need to use multiple imputation, but in case it is not, then you can use your single imputation. Now that we have understood what single and multiple imputation is, let's look at the different techniques. So the techniques might be similar between single and multiple imputation, but there are certain different ones for single imputation alone and several for multiple imputation alone. So over here, I just wanted to quickly show you Rubin's multiple imputation. This is how basically multiple imputation is performed. When we have incomplete data, we would take different scenarios. So we know some it in case like how we usually do it is we take certain sample data and replace the missing data with it, and then come up with best to worst case sort of scenarios of how our results are coming up. And then based on those cumulative responses, we pool the results and then select the one that feels most accurate. So under single and multiple imputation, the different techniques which are present are, first one, hot take imputation. So hot take imputation is this type of imputation method where when certain data is missing, consider a questionnaire. So consider a healthcare questionnaire where you're asking certain data to the patient about his allergies or other health conditions. So in case some data is missing, what hot deck imputation does is it finds similar questions in the same questionnaire in the same data set and tries to use that to replace it. Coming to cold deck imputation. So cold deck imputation is very similar to hot deck imputation, but the only difference being instead of using the same data set, we try to find, say, questionnaires or surveys that have been conducted in the past and then use similar results of those to, replace the missing value over here. Mean imputation. So mean imputation is basically what we do over here is we take the different values present in the data set and take the average of it and then try to fill in the missing value. So mean over here is nothing but average. Regression imputation. So regression imputation is slightly complex. So I would like to show you a small Excel to take you through it. So if you can see this table over here, it includes four columns, X, Y, Z, and W. So over here, our column Y has two missing data highlighted in yellow and written as NA. So in case of regression technique, what happens is it will try to see the value of Y and correlate it to the other column. So it will correlate it to X, correlate it to Z, correlate it to W. And then based on this, it will see which correlates with Y the most closely and then use that for replacing the value. So not only does it find how closely does it correlate, but we also try to come up with some sort of a formula. So it could be something as Y equal to A plus B X. So, this sort of helps us connect how Y and B are related, and we use this to easily compute the value of NA using the similar value of X in the same index. So that is regression imputation. These are the different techniques. So these can be applied on both simple as well as multiple imputation. As I mentioned earlier, generally even though single imputation is more widely used, but it is multiple imputation because of its accuracy, which is generally favored. Question 6. Explain what is KPI, design of experiments, and the 80-20 rule. So, other ways to frame this question. KPI is nothing but key performance indicator. It is used to measure the performance of business processes or reports. So the other way to frame what is KPI would be how would you check the performance of business processes? The 80-20 rule is also known as the Pareto Principle. So in case you are asked what is Pareto Principle, do not get confused. It is the same thing. So let's start with KPI. What exactly is KPI? So KPI, as I mentioned, is nothing but a key performance indicator. It is usually kept in mind while you're setting up a business process or a report. What it helps keep track of is you set up certain indicators that you will be using to measure whether the process or the report is fulfilling its purpose or not. And if it is, to what extent is it fulfilling its purpose? So this indicator basically helps in identifying how well the report or the process is performing. Design of experiments. So design of experiments is nothing but the initial process that you use to split your data and your sample and set up the data for a more statistical process. So basically for the team to, run all the analysis and everything. It is basically how you would design the data for smaller experiments to take place. Last is the 80-20 rule, also known as the Pareto Principle. So this is something that as a data analyst or a data scientist, you would actually be using quite often. It basically says that whenever you're, say, considering you have certain clients of yours and you're trying to identify which are those top clients which are leading to most of your income. So, what it basically says is that it would only be 20% of your clients which would actually be leading to 80% of the profit. The remaining 80% of the clients would just be giving that small tail of 20% income. So when I worked at Amazon, I worked on transportation invoices. I used to basically audit carrier invoices sent by different carriers like DHL, FedEx. And what we would try to often see is how the payments are working. So are our systems calculating the payments correctly? Are the carriers sending us the payments, the invoices correctly? So what we would often find is that 80% of the miscalculation of the price that would occur would be only because of 20% of the errors. And this was actually something that we used very often and it is very commonly known. So it is good to keep in mind. A small image over here showing, so it basically says that 80% of the effort leads to 80% of the result, which basically means that if you invest into the 80% which is giving you your result, it will improve your result. You do not need to focus on the tail, which gives you only the 20%. Focus instead on the 20% of the clients, which is leading to the 80%. So since I want to cover the different categories of questions, I will not go more into the other content related questions. However, I would recommend that you pause over here and go through the different questions that I've mentioned over here, since these are questions that are quite commonly asked, in fact, by most of the companies. So take a second, pause, and also do like the video if you're enjoying it so far. In no interview are they going to ask only question and answer sort of things, because it's the interviewer trying to understand the candidate and not take an exam. So let's move on to the question. What statistical methods do you find useful for data analysts? Have you ever used any? What were the results? So there are a couple of different data analyst statistical methods. I've chosen the ones which I found most useful to me and the most common. So let's take a look at the ones. So starting with the first one, which is Markov process. Markov process is this process which is based purely on probability. So if you can see this image over here, the most common example application of Markov process is in weather prediction. So I'm going to explain this process with a small Excel to explain it more clearly. Since this is used in weather prediction, let's take a similar example, considering today as day 0, tomorrow as day 1, and then day 2. So what Markov process does is it uses probability to make predictions about the future. So say today is a sunny day. There is basically a 70% chance that tomorrow will also be a sunny day. And if tomorrow is a sunny day, then again, there is again a 70% chance that day after will be a sunny day, which is day 2. Now consider that today is a sunny day, but tomorrow does not turn out to be a sunny day and it's a rainy day. So this would be 30% chance. And in case day 1 is a rainy day, so how would we predict about day 2? So what it basically says is on day 2, there is a 20% chance it will go back to a sunny day, or the other way it would go is rainy again. And this would be an 80% chance. So this is how we continuously keep trying to predict. So every time you go to your phone and you see the 7-day weather prediction, just remember this is basically what is being used to predict it. So coming back to this image, if you can see, this basically says that if this is a sunny day, there's a 30% chance the next day will be a rainy day, and 70% chance that the next day will be a sunny day. If the next day does turn out to be a rainy day, then there is an 80% chance that day 2 will be rainy day and 20% chance that day 2 will be a sunny day. Coming to spatial and cluster processes. So, spatial process is nothing but how we basically see the world, how we figure out where we are, and which is why the most common application of it is in geographic information systems. So every time you open Google Maps and try to find the most optimized route or try to locate, say, medical stores or electronic stores, so what it does is it uses the spatial process to identify where you are, where items are located, and then tell you the best route possible. The other one, clustering processes. So clustering processes is nothing but when you take certain like huge amounts of data, and obviously we cannot go through each and every one. So what clustering process does, it helps group or cluster things up based on similarities. So a common example of this would be to identify patterns. Say an online company which sells goods, if they want to see which good of theirs is making the most profit, they could do clustering to see which goods are leading, they have the most sales, which ones might not have the huge sales but might be huge in numbers. So such things can be done using clustering processes. Other processes for statistics include looking at ranks, percentiles, identifying outliers, imputation techniques. As we have discussed, imputation is nothing but the process of adding data wherever it is missing. Another process which is used is the simplex algorithm. So the simplex algorithm is basically used in terms of whenever there is some sort of an equality. What the simplex algorithm does is it converts that inequality into an equality and then tries to solve it and come up with the solution. So these are the different statistical methods that are used. If you have used any, please do mention them with the examples and of how you use them and how they helped you out. Question 8. How can you handle a situation with suspected or missing data? So this question we have already covered in the past where we spoke about what is imputation. The reason I have taken this question again is to illustrate that the interviewer could be asking question in two separate ways. So if he's asking directly what is imputation, he's asking more from a theoretical standpoint and it is okay to just answer that much. But if he's asking how would you handle, it is more of the interviewer trying to understand your mindset, your thinking process, get into what your personality is like. Do you have what it takes? Have the required problem solving skills? And also based on how your past experiences have trained you to solve certain situations. So coming back to the question, how can you handle a situation with suspected or missing data? So since this has been asked in a more personal way, you would definitely want to give the answer a more personal touch by saying, this was an example where certain of my data was missing, and these were the steps I took to handle the situation. So in the answer, I'll be taking you through the steps, but please do remember if you're asked the question as how would you handle a situation, try to personalize the answer. Even if you don't have any experience, put yourself in the shoes of someone who you think is handling such a thing and try to answer in that way. It will definitely help. So let's move on to the answer. So the steps you would follow when data is missing is you would prepare a validation report. So as we had discussed earlier, the only cases in which you would actually end up adding data is if certain criteria are satisfied. So if the missing percentage is greater than a certain percentage, but not too great again, if the missing data is not dependent on too many variables, then you can use the imputation technique. But in certain other cases, probably deleting those data points might make the answer more accurate. So data analysis, data scientists, job roles are a lot of intuition. Keep that in mind and let that come out. So after you prepare a validation report, you would experience personnel should examine the suspicious data to see if, as I mentioned, does it fall under certain criteria? Does it have any dependability? Does it not have? Invalid data should be assigned and replaced with a validation code. To work on missing data, use the best analysis strategy like deletion, single imputation, model-based methods. This image over here takes you through the steps of how would you handle data. First thing you would see is if deleting is a smart option. You would only delete if it is less than 5% missingness or if the missing percentage is way too great. If it is between that certain sweet spot, then you might want to, impute the data instead and try and get better results. So under imputation, you would see if it is a general problem, time series problem. If it is a general problem, then you would make your, based on the different methods that we have discussed, how would you impute? You would take your methods and then use those required methods to fill in the missing data. Question 9. How do you detect if an observation is an outlier? So, outlier is a word that you must have heard me use quite a lot in this video. Outlier is nothing but something that stands out in your data set. So, if there is all of your data points or majority of it is following a certain norm, but few of them are standing out, those would be nothing but the outliers. But here's something tricky. So, an outlier can also be an influential observation. So, what is an influential observation? It is different from an outlier. Outliers would be the errors or the points that can be excluded. But influential data points are the data points which, if left out of your observation, completely change the result altogether. So in such cases, you would want to keep these, data points and see how they are affecting your results. And if the effect on the result is way too much, that is when we call it an influential observation and bring it back into our data set. So we see how it is changing our result. So let's look into the different methods that can be used to identify outliers. I'm going to be mainly showing two methods, which is Z-score or standard deviation, and the other one being IQR, interquartile range. So the first method, which is Z-score, it basically calculates a score based on the standard deviation and tries to identify deviance in the data set. So certain things that need to be kept in mind while using the Z-score is ensure that your data is normally distributed. It is not applicable to very small sets of data, and in case there are too many outliers, your Z-score can be impacted. So make sure that there are not too many outliers, and if they are, be careful to omit those. Coming to the second method, which is IQR, interquartile range. So what this does is it is based on box plots, and based on this it tries to find the difference between the third quartile and the first quartile. This is nothing but approximately close to 2.698 standard deviations. There are a couple of other methods also like DB scan, clustering, isolation forests, and robust random cut forests, which you can look into to find outliers. So as we discussed in the earlier slide, that certain outliers can be influential points. So this is an example which has been chosen to, illustrate this. So in these data points, if you see, most of them are clustered around this line. But there are two data points, one over here in the x direction and one in the y direction, that are quite far away from this normal deviation. So in this case, the x, because it follows in the line, turns out to be an influential point and it is along the x-axis, whereas the one along the y-axis is an outlier. So that's it with regards to the question and answer session. However, before I leave, I do want you guys to go through these other sort of questions. So these are more personality based or team fit and ethic questions that you should know and you should be able to answer, because these mostly will be asked. So, have you ever had a difference of opinion with your manager? How did you handle it? Have you ever had a fight with a teammate? What caused it? Would also be good to show how you handled it. And it is always better to, say that you dealt with it rather than say that you hid from the situation, because it says a lot about your personality. How would you handle a teammate who is not contributing in the project? What has been your best project so far? Why would you call it a success? What, as per you, are your best skills? So, this is definitely a question that can replace the one, what do you think, you need to become a data scientist? Because all of these basically test your knowledge of how much you know a data scientist, how much do you correlate with it, how much past experience can you show for it. Thank you for watching the video. Please like the video and share it with your peers. If you like the video, then also subscribe to our YouTube channel, OdinSchool, for many more such fun and interesting videos.